Alright, you little mathematicians, today we're going to learn how to represent data using histograms. And by the way, this is not Instagram, so no selfies allowed. Alright, so a histogram is a data display that divides the range of data into equal intervals and shows how often each interval occurs in the data set. It's usually used for large sets of data. That's really important. We don't want to make a dot plot. If we have 1,000 pieces of data that we want to put on that we want to display, we don't want to make a dot plot because we'll be making 1,000 dots, and that's just simply too many. So what the brilliance of a histogram is that instead of, it sort of divides things up into intervals. So you can see down here, we have these 2-hour intervals from 6 to 7:59, from 8 to 9:59, from 10 to 11:59. So we're grouping things still, but not just like dividing them up by minute, right? It's not like you have one for 6 o'clock, one for 6:01, one for 6:02. You just have this big group. So, you can imagine this could be like the number of phone calls that, a hospital gets, well, in a normal time of day. Well, between 6 and 7:59 a.m., they got 180 phone calls in that 2-hour span. But then from 8 to 9:59, they got something like 110. From 10 to 11:59, that 2-hour span, they got something like 130. From 12 to 1:59, something like 100. And so, again, the brilliance of the histogram is that it allows you to clump data together. You can still see, people call really early and then it slows down for a while, but then it picked up again later in the day, without having to have a minute-by-minute mapping out of things. So now we're going to make our own histogram. With this data here, the scores obtained by 40 students in a mathematics quiz are recorded in the table below. So here's our table. So how many students got a score of 1 to 2? 8 of them did. How many students got a score of 3 to 4? 8 again. How many got 5 to 6? 10. So here are our scores down here. I put them in our intervals, right? 1 to 2, 3 to 4, 5 to 6, etc. And then here's the number of students. So we're going to map this out. So if the scores of 1 to 2, there was a frequency of 8. So we'll make a bar like that. And now a score of 3 to 4 also had a frequency of 8. So we'll make another bar. It's pretty much the same. I'm doing my best to make these the same. And then 5 to 6, there were 10 students. Oh no. 10 students. And then 7 to 8, there were 9, so I'm going to put it somewhere between the 8 and the 10 there. And then only 5 students were able to score between a 9 and a 10, so represent that right there. So you can see how I've taken this data and built a histogram. I realize it is not the most beautiful histogram, but I've done my best. And now that we know how to build a histogram, I want to make sure that we can look at a histogram that's already built and interpret it to get some information from it. So this problem is just asking us it shows the highest temperature recorded during December, each day during December for one city. And the temperature was recorded to the nearest degree. Wow, this is worded poorly in here, I'm realizing. Briefly describe the data. Okay, so how many days, I can just ask you as a student, how many days was the highest temperature between 34 and 36 degrees? Right, there were 6 days where the highest temperature was between 34 and 36. And, you can kind of look at this and say, well, the average was probably somewhere around here, right? And if you had to say this graph was skewed, you would say it was skewed to the left, skewed falling down here. This is a pretty sharp decline here, and then this one kind of falls out a little further to the left, so it's skewed left. One thing to also notice is that these gaps the intervals are equivalent, right? Between 22, this is either 22, 23, or 24 degrees, 24, 25, 25, 26, 27, 28, 29, 30, so they're each in a little 3-degree intervals there. All right, great work. Do the Google form, and we'll see you in class tomorrow. Thanks.